probability is the topic. The diagram is a possibility diagram. So I got two fair six-sided dice. How many sides are there? 6. So there are two ways to write down the sample space. The first is using a possibility diagram like this. So this one is called die 1. The singular for dice is DIE, die, and then this one is called die 2. Now there's a bit of difference. So we will put the die 1 here, die 2 here. If you put 1 here, 2 here, then the way to write the sample space will be a bit different. So I'll write as 1, 2, 3, 4, 5, 6. Okay, I'll use another color to help you see better. 1, 2, 3, 4, 5, 6. Now the possibility diagram is basically to list out all the sample space, which is all the possible outcomes. So there are 3 ways to do it. I will show you through these 2 examples. There are 3 ways. Now the second example is not in your resource book. I designed the question to show you what I did. Okay, so the first way it would be like this. Okay, so what we'll do is we'll write down the outcome. So it'll be the first one is a 1, and then the second one is a 1, 1. Okay, so we will list out all. You can start listing also. I'll give you another example. Okay, the first one is a 1, the second one is a 2. So I'll keep listing like that. So can you list out and then see how many total outcomes are there? Okay, I give you some time to complete it. Basically, it should look like that. Now this symbol is for probability. So the question is find the probability that both numbers are the same. Okay, let's count. How many of them have the same number? 6, right? Where are they? 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. Then you must be asking, it's quite obvious one. I spent so much time draw this for what? Okay, but the question sometimes did ask you to list out all the possibility using a diagram. So we just learn from it. So the answers will be 1, 2, 3, 4, 5, 6. There are 6. Out of how many? You learn in lower sec. So total, how many possible outcomes are there total? 36, right? So the top number is for the outcomes for this event. The bottom is the total possible outcomes. Again, the top one is for the event. Now this event is for the same number. So total, there are 6 of them for this event, total 6 outcomes. Now the bottom one is for the total possible ones. Total possible outcomes. So there are 36 possible outcomes. If you count 6 times 6 is 36. What's wrong with the final answer? Yeah, you must simplify. It's not simplified yet. So the answer must be 1 over 6. Now we got a problem now. We got a very big problem coming up. Find that the sum is 6. Is it easy to see which one the sum is 6? So this is not a very good possibility diagram. So let me introduce you a second type, which looks exactly the same. We still use a possibility diagram. So we have 1, 2, 3, 4, 5, 6. I'm going to use the same color now. 1, 2, 3, 4, 5, 6. This is called die 2, and then the top one is die 1. Doesn't matter, because what we are going to do now is, okay, look up, we are going to find the sum. So put a plus symbol here. What you do now is just add them up. 1 plus 1, 2. 2 plus 1, 3. 3 plus 1, 4. You definitely see a pattern. 2, 3, 4, 5, 6, 7. Okay, one more time. 1 plus 2, 2 plus 2, 3 plus 2, you see a pattern, 3, 4, 5, 6, 7, 8. 1 plus 3, 2 plus 3, 3 plus 3. Now you can see a pattern both vertically and horizontally. So you just follow the pattern. 4, 5, 6, 7, 8, 9, 2, 3, 4, 5, 6, 7. 11, 12. The alignment is a bit out, but never mind. Because at the end of the day, right, we want to count how many of them the sum is 6. Now can you look at the new possibility diagram? How many of them the sum is 6? Wow, you count so fast. Okay, let's do this. Usually I will circle. I will use a pencil and I'll circle. So let's circle in black. How many again? 5. 1, 2, 3, 4, 5. Got 6 there? No more. Did I miss out any? No. Okay, so it's 5. 5 of them out of 36. Now, what's the limitation of this diagram? I must do another one that is for products. Yeah, a fun face like the jaw drop. Well, every time I do one question, I got to do this. I will skip this example. The answer is 1 out of 4. You may think that it's half, right? It's not half, Okay, it's actually 1 out of 4. Okay, well, how do you get 1 out of 4? There will be 9 out of 36. So the final answer is 1 out of 4. Okay. You realize that if you don't use a possibility diagram, you will lose track halfway. So you need a diagram. Okay, so let's do this one last example. I told you there are 3 types, right? The first type is just list out all the possible, like green, blue, blue, green, 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 blue, blue. Just list out all the possible outcomes. The second type, if they ask you to do sum, you do the sum. If they ask you to do the product, you do the product. Okay, I will show you the third type. I will, yeah, so later you see. Now the story goes like this. I got 4 cards. And I draw 2 cards, but I don't replace. Every time I draw one, I don't replace. I just draw one, I just draw a second one. So I have the outcomes as 1, 2, 3, 4. 1, 2, 3, 4. Okay, let's see what happens. I am going to do a product. So I will multiply, which is the same as part C just now, but let's do it here. Okay, let's multiply. 1 times 1, 2 times 1, 3 times 1, 4 times 1. Now you realize I never put here card 1, card 2, because it doesn't matter. The cards are going to multiply, right? So it doesn't matter. This one also doesn't matter, but this one does matter. This one quite important. So for multiplication, it doesn't matter which one multiply by which one. 1 times 2, 2 times 2. Then you see a pattern, right? 2, 4, 6, 8, 3, 6, 9, 12, 4, 8, 12, 16. Now there's a mistake with this diagram. There's a very, very serious mistake. Can anyone spot what's the big mistake? There's one of each kind. He says something about the diagonal. So what happened to the diagonals? Same number, both cards same number. Both cards same number is impossible. After I take out a 1, can I still take out another 1? So this is impossible. So we have to put a cross. Okay, this is the lesson of the day. This is very important. Okay, what else is impossible? I cannot take out a 2 and then take out another 2, right? It is impossible. Another one? I cannot take out a 3 and then still take out another 3, right? Okay, the last one, if I first one I take out a 4, can I take out another 4 after that if I never replace? No, right? Okay, why is this important? How many of these numbers are prime? Okay, first row, which of these numbers are prime? Let's revise. The first one is a 2. Okay, 2 is the very first prime number, then we follow by 3. Second row, Just a 2. You see I'm circling, it's perfectly okay to circle. Then the third row and the last row. Don't have lah because they're all even numbers more than 2. So how many of them? So the probability that is a prime number is 4 out of 12, not 16. Because there are 4 numbers missing. Right? How many possible outcomes? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And final answer is 1/3. Okay, so that's the end of the video. Kia, can you help me?